Good morning, everyone. This is lesson 5.6, which is linear inequalities into variables. So we did regular inequalities, and now what we're doing, the difference is that you are going to have two variables. And so most of the time you're going to have x and y. These are going to look like linear equations, like y equals mx plus b, except instead of equal signs, we are going to have the inequality signs. The things that you're going to have to know is you're going to have to be able to check to see if something is a solution. So that's the first thing that we're going to be doing. The second thing is you are going to have to know how to graph them. You're going to have to know how to write them from word problems. And also you're going to have to be able to solve those real life word problems. So let's get started with the first section of our notes. This one is just a reminder. These are not anything new, but instead of equal signs, it is replaced with inequality symbols. And so we just wanted to remind you what those are. The first one is less than. And then when you put the line underneath it, that is less than. But since it has another part, it is or equal to. So that can have two different parts. It can either be less than or equal to. And then it's the same thing with these other guys pointing in the other direction. So the top one over here, this is greater than. And then the second one, it still has that greater than part. So it's still greater than. But it also has the line underneath it, so it adds an extra part. So it could be greater than or equal to, just like the other one is less than or equal to. This is greater than or equal to. So that's just a reminder about the symbols that we are using instead of the equal symbol. In this portion of your notes, what you're doing, it wants to know if an ordered pair is a solution or not. And so remember what a solution is it makes the inequality true. So it makes the inequality true. And so what we're going to do is we are going to substitute the given ordered pair into the equation to see if it makes it true or not. Now, remember in an ordered pair, you've got two numbers. The first one is the x and the second one is the y. So on number 1, we are plugging in 3 for x and we're plugging in 2 for y. So we're going to substitute those values in and see if it makes a true statement or not. So when I plug in x for 3 for x, I'm going to have 3 plus, and I'm substituting 2 for y. So 3 plus 2, and we are testing to see, is it greater than 5? That's what we want to know. Is that greater than 5? So when I work this out, what is 3 plus 2? Well, that equals 5. And over here I've got 5. And we're testing to see, is it greater than? Is 5 greater than itself? No. It is equal to itself. So since it doesn't have the or equal to part, this is not a true statement, so that means it is not a solution. So that ordered pair would not be a solution to that given inequality. Let's try another one. Let's move to number 2. On number 2, it's given us an ordered pair of 5, 3. So my x is going to be 5, and 3 is going to be my y. So let's go ahead and plug those in. I have 5 minus, for y, I'm plugging in 3, and we are testing to see, is it greater than or equal to 2? Okay, so let's work that out. What is 5 minus 3? Well, it's 2. And we're testing to see if it's greater than or equal to 2. Is 2 greater than itself? No, it's not. That would take us back to number 1. So it's not, it would take us back to here where it would be equal to itself. So 2 is not equal to it. 2 is not greater than itself, but it is equal to itself. So since it adds that extra part, this is true. So that would be yes, because of the or equal to part. It would be a solution. Okay, now I want you to try number 3 on your own. Be careful plugging in, okay? So go ahead and pause the video, you try number 3, and then when you finish it, check your answer. Okay, this next section is over graphing the inequalities. And again, this is something that you've done before, so just a reminder, when you are graphing these, because of the symbols, we do different things with our lines than when we are graphing actual lines. So whenever you've got a just greater than or less than symbol, you remember that you're going to draw a dotted line instead of a solid line. You're only going to use a solid line if you have the or equal to part. So that's when you would draw a solid line like that, what we're used to. Okay, and then this also tells you where you're going to shade. You shade above the line if it's greater than or equal to, and you're going to shade below the line if we're talking about less than or equal to. Okay, so this is a really important thing for you to remember and to memorize. It's not something that's on your formula chart, so you need to make sure that you understand that. Okay, we're actually going to start with number 6, and so I want you to look at number 6 with me. When you're ready to graph this, you basically graph it just like a line. So you're going to start by looking at the pieces that you know. On this, I know that I am going to start at the back. That's my y-intercept is +1. So go ahead and draw a dot on +1. Okay? And then I know that this is my slope. So my slope is 3/1. So from here, I would go up 3 and over 1 and put a dot. Okay? And then I can also go down 3 into the left 1. All right? So now that I've got that, go ahead and connect them. Now, you have to look at your symbol to know what kind of line you're going to have. So if I look at less than, it tells me that I am going to have a dotted line because it's not or equal to. So go ahead and connect your line with a dotted line. Okay? And then since it is less than, I want to shade this with all numbers less than that. So I am going to shade below my line. Here's my less than symbol. It tells me I'm going to shade below. So all of our solutions to this inequality would be in this region. Remember, in inequalities, there's not just one solution. There are several. Okay? Now, could there be solutions on this line? Well, the answer is no, because it is dotted. So this would be no. In this instance, the solutions would not be on the line because it is dotted. All right? And then it's taking it a bit further and asking us, is -1, 0 a solution? So if I go to the left 1 and I don't go anywhere, I'm looking at this point right here. And is that in my shaded region? No, it is not. So that would not be a solution. And that's how they ask you these questions on STAR. They would give you different answer choices and you have to find the solution. Okay, now I want you to go ahead and I want you to do number 4 and number 5. These are two weird lines because they just are X and Y. So remember what we've taught you about those lines. It's kind of our weird lines. And you give those a try on your own. So push pause now and try those on your own. Okay, I'm going to do number 8 with you because we've got to rearrange it a little bit. It needs to be in y equals order for us to be able to graph it. So I'm going to do that first. I'm going to rewrite it. We have negative x plus 2y is greater than 2. To get it in y equals form, the first thing I need to do is to move over my x. So to move over the x, I'm going to add x to both sides of my inequality. And then I'm going to be left with 2y is greater than x plus 2. Okay, I'm still not done. I need to divide both sides by 2. And remember, when you divide, you're dividing everything by 2. Okay, it's kind of like distributing, except we're dividing. Okay, so my final answer is going to be y is greater than 1/2 x plus 1. So that's my inequality that I need to graph. So where am I going to start? My y-intercept is 1, so go ahead and put a dot on 1. And then your slope is positive 1 over 2. So remember, that's rise over run. So from 1, I'm going to go up 1 and over 2 and put a dot. And then up 1 and over 2 and put a dot. Now, what kind of line am I going to have? Remember that you want to look at your symbol, and so our symbol is greater than, indicating that we are going to have a dotted line. Okay, so I'm going to go ahead and connect those with my dotted line. And since it is greater than, my solutions are going to be above the line. So you need to shade above. Sorry, that E's kind of ghetto looking. It's all right. You can write it better. And so you're going to shade above that line. Okay? Now, you have to think, because where the star people think they're all tricky pants is when they give you a point on the line. And so if they gave you a point on the line, would it be a solution? and you always say no